The ocean is surely a thing of beauty. Powerful and very, very dangerous beauty. Some people even claim that surviving in the freezing vacuum of space might be more likely than escaping from the clutches of the ocean. But space is often called the final frontier for us humans. It's vast, dark, and probably filled with all kinds of terrors. You can't but expect some disaster at every turn, and we still don't know whether some hostile civilizations are lurking out there, waiting for us to come closer. But the ocean on our home planet is no less scary. It's vast and mostly unexplored. We don't know what kind of monsters might still be hiding in its extreme depths. And still, it has been romanticized much more than the cosmos. Unlike space, the ocean is something familiar. Only a few people have floated in zero gravity above the atmosphere of our planet, but lots of people have felt the ocean playing with their toes at least once in their lives. We also have some general idea of what to expect from it. Fish, scary-looking fish, monster fish, and a lot of water. But experts claim that this assumption is terribly wrong. We have explored and mapped only 5% of the ocean. So, can we really say that we know what's going on down there? It means that what actually lives in the remaining 95% of the ocean is unknown. Maybe there are some real-life monsters roaming the waters out there. We do know that some pretty creepy creatures live in the deepest places of the world's oceans, like the Mariana Trench. For example, look at this. This monster is known as the frilled shark. It looks like an overgrown eel and has gills lined with red fringe at the edges, hence the name. The creature's horrifying mouth is lined up with 25 rows of razor-sharp, backward-facing teeth. The shark hovers in the water, waiting to charge at its prey like a snake. Or this one, the deep-sea hatchetfish. It has a ridiculously skinny body and large tubular eyes pointing upward. The fish might look fragile. Even the largest specimens reach only 6 inches in length, but it can live at a depth of 5,000 feet. The hatchetfish can also regulate its glow depending on the amount of light around. That's how they camouflage. With its protruding, flattened snout and pink-colored skin, the goblin shark looks like a visitor from another planet. The creature's terrifying jaws are attached to elastic ligaments. When prey comes too close, the shark catapults its mouth forward to catch it. If your mouth could do the same, you would be able to eat things dangling pretty far away from your face. Or look at this thing. It's the ping-pong tree sponge. It may look like a beautiful ethereal lamp, but its appearance is deceptive. This creature with a funny name is a dangerous carnivorous sponge living at the depths of nearly 9,000 feet. The soft-looking balls are covered in minuscule hook-shaped spikes. They trap careless sea inhabitants and consume them, which looks as if the prey simply melts away on the translucent globes. If these monsters are what we know about, what outlandish creatures might still be lurking there? The ocean is far from tamed. So let's admit it, both Earth's oceans and outer space are terrifying in their own unique ways. But which one is scarier? What do marine biologists and astronomers have to tell us? Oh, the verdict might actually surprise you. Lots of scientists believe that the ocean is way scarier than space. They say they wouldn't turn their back on the ocean. There are many more ways the ocean can hurt you than the dangers you may encounter in space. From venomous animals to the pressure of the deep sea and a lack of oxygen. And what do you think? What is scarier, the ocean or outer space?
In the past 30 years, scientists have made an incredible discovery of a new creature living deep beneath the surface of the ocean. And the name of the creature is the harp sponge. Now, if you're wondering why it took so long to come across this animal, then I might have the answer. These creatures typically hang out at a depth of roughly 11,100 feet beneath the ocean's waves. The sponge species was first discovered off the coast of California thanks to a robot that was sturdy enough to explore those crazy depths the ocean has to offer. This is no doubt an area of the planet where even the most benign-looking creatures can be potentially dangerous. But even scientists were surprised to find that this creature was more than just a sponge. Now, this might seem obvious, but the harp sponge got its name because its basic structure, referred to as a vein, is the same shape as a harp. Each vein is made up of a horizontal branch supporting several parallel vertical branches. But don't let the harp sponge's fanciful and amusing appearance or its non-intimidating name fool you. Yeah, the harp sponge is very much a deep-sea hunter. It has a unique ability to capture and envelop small animals using its rhizoids, short, thin fibers. With their help, the harp sponge clings on to the soft muddy bottom and catches tiny creatures that get swept into its branches by deep-sea currents. Uh-oh. Other sponge creatures often feed by pulling bacteria and bits of organic matter from the seawater and filtering them through their bodies. But not our harp sponge. Instead, it snatches its future meal with minuscule barbed hooks that cover each of the harp sponge's branches. Now, harp sponges prefer tiny crustaceans like crabs, crayfish, shrimps, and prawns. Once the harp sponge has one of them in its clutches, it envelops the animal in a thin membrane before slowly beginning to digest it. So, pal, what's eating you? Oh, Harpo? Too bad. Researchers believe that harp sponges use this method of feeding because there aren't enough nutrients that deep down. This makes traditional filter feeding less effective. Research has shown that the creature is still in the process of evolving. Early harp sponges, researchers found, only had 2 veins, but later, scientists discovered other harp sponges that had 6 veins. The harp sponge might have evolved this elaborate candle holder-like structure to increase its surface area. In general, harp sponges typically grow up to a length of 1 foot, but researchers have seen a creature that was 2 feet in length. The harp sponge is not only very unusual, but also beautiful to look at. See those tiny white balls on top of the branches? Now, why don't we look at some other creatures that live below the photic zone of Earth's oceans? The photic zone means the area beneath the ocean's surface that still receives some sunlight. Thanks to this, there are loads of different creatures and organisms living there. Any animal living beyond this layer qualifies as a deep-sea creature. The Tomopterus worm is a segmented worm you can find in the twilight zone of the ocean. This is the area that lies between 650 and 3,300 feet beneath the surface. These creatures are often no more than 1 inch long, but the largest of them can grow up to 1 foot. While swimming around and feeding, these worms do what researchers describe as an amazing smooth dance. That's because the creatures can swim extremely quickly and maneuver at tight angles with ease. Now, I know most people hear the word worm and think of the common earthworm, so it's quite interesting to know there's a deep-sea worm out there that never leaves the water during its entire life. Similarly, most of us try to avoid jellyfish that either rest on the sand or sit on top of the ocean waves. This isn't the case with a Chrysota jelly. That's a deep-sea creature too. This beautiful jellyfish is mostly ruby red, bright orange, or electric purple. That's what helped researchers realize they had found a new species of jellyfish. The creature grows to a maximum size of 1 inch across. It has tentacles that stretch out in every direction. Now, if you come close to this jellyfish, it'll pull all these tentacles in toward its body before rapidly swimming away to avoid danger. Yes, you are dangerous. The Chrysota jelly is extremely rare. You won't see it very often. You might need to borrow that deep-sea diving robot I mentioned earlier. While worms and jellyfish might seem quite harmless, this isn't the case with the Pacific viperfish. Ooh. This creature is equipped with a noticeably big mouth, like me, and the needle-like teeth inside are key to its hunting strategy. Pacific viperfish live at around 5,000 feet below the ocean surface, but they're among those numerous marine animals that migrate each night from the ocean depths toward shallower waters to dine. What's on the menu for dinner tonight? Lots of small fish and shrimp. The creature can grow up to 12 inches in length. Its 2 front fangs, which stick up from the fish's bottom jaw past its own eyes, are especially dramatic. When the fish unhinges its jaw, its mouth can open wide enough to engulf smaller animals, and the teeth form a cage to prevent an escape. Now, have you ever seen an underwater creature that looks like a strawberry? Trust me, it does exist. Just look at these dots on the strawberry squid. The creature has a big eye and a smaller one. You might think this unconventional pairing would be awkward and uncomfortable, but it's actually the opposite. The big left eye looks upward. It spots shadows cast by other animals in the dimly lit waters above. The eye's tubular shape helps it collect as much light as possible. On the other side of the squid's head, you can see its right eye. It's small and looks downward. This eye searches for flashes of bioluminescence produced by animals lurking in the darker waters below. Now, bioluminescence means the production and emission of light by living organisms. By the way, the squid has a nickname. And no, it's not Squiggy, although that's a great one. It's known as the cockeyed squid. This is simply due to the remarkable difference in size between its two eyes. I think I like Squiggy better, and so it goes. Since light doesn't reach the deep sea, the strawberry squid's body actually looks black. This helps the creature hide from enemies, such as sharks and dolphins. In general, the strawberry squid grows to a length of 5 inches. It typically lives around 3,000 feet below the surface, but floats to shallower waters at night. Now, the feather star is a marine creature without a backbone, but with feather-like arms that radiate from the center of its body. These creatures first appeared around 200 million years ago. Related to sea stars, they look like a flower, but if you approach them, they'll quickly swim away. But not all feather stars can swim. Many species can only crawl along the bottom of the seafloor. Like some of the other deep-sea creatures we've looked at, the feather star can adapt to its surroundings. It has a creepy ability to shed its arms, the same way some lizards can shed their tails. This also helps them escape from their enemies. Feather stars live all across the globe, from the equator to the poles, from the shallow waters on top of reefs to the deep, deep sea. Now, given that we're dealing with mysterious creatures, the name of this one is quite fitting. The swift vampire squid should be the official symbol of life in the deep sea. The animal has a dark red body, huge blue eyes, and a cloak-like web that stretches between its 8 arms. This, along with its name, may suggest that the creature is some form of a terrifying hunter. In reality, though, the vampire squid is a soft-bodied, timid creature, about the size, shape, and color of a football. It grows to roughly 12 inches in length and lives 3,000 feet below the waves. There's almost no oxygen there, but also relatively few predators. Whew, I think I'll need to decompress from this one.
Many terrifying animals live deep beyond the waves, like this vampire squid living 3,000 feet below the surface in almost complete darkness. This animal has a cloak, like a vampire's. That's why it's called the vampire squid. Deep down at the bottom, it can't use ink to defend itself. So this animal has developed an unusual tactic. It glows slightly to scare away predators. If this tactic fails, the vampire squid can turn its body inside out, revealing tiny spikes. When you translate its scientific name, Vampiroteuthis infernalis, it literally means vampire squid from the nether. Despite its terrifying looks, it's a harmless ocean animal. This previous creature was not from space, but this object definitely is. Before Elon Musk found a way to reuse rockets, NASA would simply drop old ones after launching astronauts into space, most of the time in the ocean or deserts. In 2012, Jeff Bezos launched a mission to find the Apollo 11 rocket. They found it by using sonar, but it was in terrible condition. It was sitting on the bottom of the ocean, not far from the predicted site. They were able to rescue the engine and reconstruct 2 of them. The most famous lost city is Atlantis, but sadly, we still haven't discovered it. However, Heraklion was also just a myth until one British pilot saw something that looked like a city while flying over the Mediterranean Sea. He reported it, and 60 years later, a group of divers went there. They were shocked when they found an entire city underwater. It was loaded with artifacts that could tell us a lot about the history of the place. Now it's one of the best underwater archaeological sites in the world. It's believed that the rising sea caused the whole city to go underwater. The Titanic sank in 1912. The wreck was claimed to be officially discovered 74 years later. In reality, though, a fisherman found the Titanic 8 years earlier while fishing in the Atlantic Ocean. He was pulling out his net when he spotted a head stuck in it. Luckily, it was just a doll's head. Years later, after the fisher had passed away, his son sold the doll to a doll collector. She did a lot of digging and research on every person who had a porcelain toy on the Titanic. She found the owner of the doll. Ava Hart was on the Titanic and had a doll with her. Ava survived the catastrophe by a miracle, but her toy didn't. Hart even wrote about the doll in her journal, and every detail matched the toy found by the fisherman. The tripod fish lives deep in the abyssal zone, around 20,000 feet below the surface. It's adapted to such immense depths and uses its tripod fins to stay still on the bottom. This creature doesn't have big eyes, but even if it did, these eyes would be useless in the darkness. Instead, the tripod fish uses its fins like antennas to detect any movement in the water. This creature doesn't have much luck when it comes to its love life, so it had to develop unique tactics to reproduce. One fish can be both male and female. The next bizarre creature is the lizardfish. It has tons of razor-sharp teeth, a huge mouth, and really big eyes, which it uses for hunting. All this makes the animal look freaky. The lizardfish lives at depths of around 11,000 feet in the midnight zone, where there is zero light. This freak of nature basically eats everything it can fit inside its mouth, from small fish to other lizardfish. On the other hand, when they see other reptile fish, they probably fall in love instead, because finding mates at those depths is not an easy task. Like the tripod fish, the lizardfish can be both male and female at the same time. When you think of a river, you usually picture it on land. Still, nature is quite unpredictable, and it created a river flowing under the ocean in California. It's running at a depth of around 2 miles. This river has everything that an ordinary river has: sunken logs, trees, and rocks. And despite its uniqueness, it's not the only one in the world. There are also others in the Amazon and Greenland. A terrifying creature was discovered near Angola's coast by a remote operating vehicle. It looks like it doesn't have a head or a body. It was sitting at a depth of around 4,350 feet below the surface. After doing research, scientists concluded it wasn't anything from a sci-fi movie. It was just a cluster of siphonophores stuck together. In 2015, some random guy was diving in Caesarea, and something shiny caught his eye. He reached out, grabbed it, and realized it was a gold coin. After that, he examined the bottom and found out that there were many more. He reported the incident to the local authorities, and they concluded that he had found Arabic treasure. The coins were made of solid 24-karat gold and were a few thousand years old, but due to the perfect salinity and temperature, they looked brand new. The coins belonged to a ship carrying cargo. It was caught up in a storm and unfortunately sank. One of the weirdest things ever discovered was found in the Baltic Sea. It's an anomaly that looks as if it was created by a different civilization. It was discovered by Swedish researchers, and they basically had no idea what it was. They had to ask tons of other scientists for their opinions. When you look at this formation from above, it's 200 feet long and looks exactly like a fallen spaceship. It's hard to believe that it's a natural formation, but spoiler alert, it's totally made by nature because the Baltic Sea has gone through many erosions throughout history. Most likely, the bizarre formation is the result of these processes. A group of divers in Madagascar were shocked when they found this 7-foot monstrosity of a knife on the seafloor. The speculation started immediately, and many said that the knife was from some giants that had fought megalodons and lived on Earth thousands and thousands of years ago. That could make a nice story, but the knife is most likely a movie prop that was lost at sea. one of the ocean's most bizarre animals is the frilled shark. It's believed that this fish is the reason for all those sea serpent stories that sea explorers of the past wrote about. These animals live pretty deep in the ocean, but sometimes they can be seen in shallow waters. It's super rare, but possible. The frilled shark has a big mouth sporting around 300 teeth. It also has a long body that looks like a lizard's, and it is truly a unique species of shark. Its prey can be half of its size because this shark's stomach is like that of a snake, and it can swallow huge fish or crustaceans. Spotting a few worms in your garden is no big deal, but after seeing a 26-foot-long one in the ocean, you will make your wetsuit a little wetter. This worm is super rare, and it's completely harmless to humans. It's actually not a giant worm. It's a cluster of zooids that are stuck together in a worm-shaped formation. They usually only eat plankton, bacteria, and other tiny things that can be found in the ocean. Probably the scariest thing in the ocean that is 100% real is the Magna Pinna, which can be found at crazy depths of 20,000 feet below the surface. This monster looks like an underwater Slender Man, but it's just a squid with really long tentacles that can reach a terrifying size of 8 feet. This guy has only been seen a few times, and basically, we don't know much about this creature so far. The giant shark that terrorized the oceans some 20 million years ago. For 13 million years, this 60-ton beast dominated the warm waters of our planet. Though, some believe that the Meg still lives in the most remote and deepest parts of the ocean. It's a hot summer day. It seems only logical to go for a swim in the sea. You're floating on your back, completely relaxed. Your eyes are closed. Your breath is even. Water's pleasantly cool around your body. A light breeze touches your face. You feel calm enough to doze off. Suddenly, something bumps into your leg. Yanked out of your half-slumber, you begin to flail until you're face-to-face with the invisible danger. Luckily, all you spot is a couple of easily recognizable fins and cute smiley snouts. Phew, just dolphins. Guess you're lucky to meet them in the wild. These amazing creatures are so close, you can touch them. You've heard people say dolphins' skin feels rubbery, but to your mind, it's more like the inner part of a hard-boiled egg. One of the animals is so close to you that its salty smell fills your nostrils. You know, though, that dolphins don't have sweat glands. It means they don't sweat and are pretty much odorless. The smell you sense comes from the water they swim in. The largest and most ferocious predator to ever haunt the oceans, the megalodon shark dominated the seas for centuries before coming extinct millions of years ago. However, scientists managed to discover very few remnants of the giant shark. Everything we know about the great beast we've learned thanks to fossils of its giant teeth, which are just about the size of the average human hand. A megalodon skeleton has never been discovered. Shark skeletons are made mostly of cartilage, meaning that they decompose quickly. Luckily, sharks continuously shed and regrow teeth throughout their lives. One shark can go through 40,000 teeth in a single lifetime. Scientists have managed to study different types of shark species based on their teeth alone. The megalodon shark had around 276 teeth. When they fell out, those teeth landed in the seabed where they stayed for millions of years, fossilizing. Scientists found those teeth, and they're the only real record we have of the megalodon's existence. Megalodon teeth have been discovered all over the world. It means that unlike other marine animals of its time, the megalodon was intercontinental. Even today, most sharks and marine animals tend to stick to one sea or ocean. The megalodon shark swam freely around the world, moving between tropical and subtropical waters. Megalodon teeth have been found in every continent apart from the freezing cold waters of Antarctica. When a megalodon makes a starring appearance in a movie or TV show, it's portrayed to look like a giant version of a great white shark. Scientists previously believed that the megalodon and the great white shark both descended from one common ancestor. Still, it's not true. In fact, it's more likely that the megalodon was the arch-enemy of the great white shark's ancestor, the broad-toothed mako shark. That means Megalodon wouldn't have looked so similar to the great white after all. In reality, the Megalodon would have a shorter nose than the great white. along with longer pectoral fins to give the giant shark a stockier and more threatening build. They both had an excellent sense of smell though, so even in prehistoric times, it wasn't a good idea to go swimming with a chunk of raw meat in hand. And it certainly isn't safe now. Whether the Meg's hiding somewhere in the depths, which some still believe is true, or it's gone forever, younger cousins will still be there waiting. Also, both of them like to go after big marine mammals, so they would certainly have things to do together. That is, until the Meg got moody and accidentally ate its friend. You never know. These guys had a different hunting style. Great whites prefer to dive straight towards their prey and find its softest spot, like exposed legs or underbelly. Sometimes, an entire tooth would be found embedded in a bone of some bigger animal, such as a whale. Without the main parts they use for swimming, poor sea animals were then helpless and unable to escape. Yet whales were just a smaller part of Megalodon's diet. Seals, sea cows, squids, dolphins, other sharks. The good old Meg probably wouldn't say no to some random school of smaller fish swimming into its mouth either. Nothing better than a good snack after a big tasty dinner. Even those giant turtles weren't safe with their thick shells. The Meg probably took them as a dare challenge on a daily basis. Scientists have used computer simulations to try and work out the hunting style of the ancient shark. Using this technology, scientists have discovered that the Megalodon's attack style was very different from that of modern-day sharks. Modern sharks dive straight for their prey's most vulnerable spot, for example, the soft underbelly of a seal. The Megalodon's teeth were uniquely suited to biting through tougher areas of cartilage. So, evidence suggests that a Megalodon would first chew the tougher fins of their prey, rendering them unable to swim away before launching into their final attack. Some people believe that the Megalodon is still alive today, lurking at the depths of the ocean's waters. But it's unlikely to be true. Megalodons are a warm water species, which means they would be unable to survive in the cold waters of the deep ocean. Most of the Megalodon's potential prey live in shallower waters, meaning there would be very little for the Megalodon to eat at deep sea level. Simply put, if there was an animal as big as the Megalodon still living today, we would have spotted it by now. It is unlikely that you'll run into a Meg though. The sharks, like us, preferred warm coastal waters. Deep ocean living would be too cold for the beasts, and food would be scarce. Their entire bodies would also have to evolve to avoid being squished by the enormous water pressure down there. It's unlikely they're still around, but not impossible. Some good news if you do run into one is that the shark is pretty unlikely to eat you. You are way too small a meal for the Megalodon, even if you have a couple of friends with you. This guy eats whales that are over 50 feet long. If you're having a beach party though, it's a different story. In a beach full of swimmers, the shark very well might creep up, scooping several humans into its giant mouth without even chewing. The fearsome name Megalodon comes from two Greek words, megas, meaning big, and odont, meaning tooth. Combined, they mean big tooth, and it certainly lives up to its name. Just one of its chompers is the same size as a human head. It had 276 humongous teeth in total, across 5 terrifying rows. In all of history, only a couple of saber-toothed cats and the T-Rex had consistently bigger teeth. Now that's a showdown I'd like to watch. The Megalodon vanished millions of years ago, leaving only huge teeth to be found by modern archaeologists. They literally disappeared with very few traces left. Scientists believe that over time, deep sea levels dropped and the ocean's temperature went down rapidly. Over a third of all marine life was wiped out as the oceans cooled and the number of animals at the bottom of the food chain plummeted. This had a catastrophic effect on the hungry predators at the top. Sorry guys. It became way too cold for these sun-loving sharks too, which made it difficult for them to reproduce since they gave birth in warm waters. The Megalodon is usually described as a sort of great white shark, but this is just a common myth. In fact, the ancestors of today's great white existed at the same time as the Meg, but they weren't best buddies and were even in competition with each other. The great white shark was a better hunter using its smaller size and agility to snap up the Meg's prey quickly. They were also known to eat Meg pups, who were only half their size. This didn't exactly help the whole extinction thing. While a great white was no match for an adult Meg in a head-to-head fight, they sure weren't scared of stealing their food. This only left the bigger fish and whales for the Meg. But its food supplies began to run out as whales swam to the cooler new seas. The whales adapted to prefer the colder temperatures, leaving our friend the Meg behind. The megalodons either starved or were frozen into extinction by the Ice Age. Rather than a great white, the megalodon is more like a modern bull shark. It had a short snout, a flat lower jaw, and huge pectoral fins to support its massive weight and size. As scary as they are, these sharks were actually caring family guys. Several megalodon nursery areas have been discovered in Florida, Maryland, and Panama. They gave birth to their young in shallow water environments. We know this from discovering loads of tiny megalodon teeth found in these areas. I wonder if they had nannies too.
Over 1,500 people lost their lives in this part of the ocean, so maybe it's a prudent idea to stay away from it. The spot where RMS Titanic sank remains dangerous. I mean, yeah, there are still huge icebergs out there, but there are even bigger threats lurking beneath the surface. Titanic is sitting about 12,500 feet underwater, nearly 400 miles southeast of Newfoundland. It's been down there for over 100 years, so over time, the wreck's just been falling apart little by little. The infamous ship is rusting just like any iron or steel structure would be underwater. Chemically, when you mix iron, oxygen, and water, that combo sets off a reaction that creates iron oxide, and that's what leads to corrosion. So, steel plates, beams, all that stuff is getting weaker. Parts of the liner are caving in, like the ceiling in the captain's bathroom and a section of the railing that collapsed not too long ago. But in the case of Titanic, a lot of that corrosion is actually being caused by iron-eating bacteria. When the Titanic sank, it split into two big pieces, the bow and the stern, which landed nearly 2,000 feet apart on the ocean floor. And now both pieces are covered in this biofilm, a living blanket of bacteria, marine fungi, and all sorts of other microbes. Over time, microbes feeding on the ship's iron have created these things called rusticles, and they are actually speeding up the wreck's decay. Scientists say the stern is breaking down way faster than the bow, mostly because it took more damage when the ship sank. And now, thanks to all that bacterial activity, the stern could be deteriorating as much as 40 years ahead of the bow. So yeah, microbes have been thriving and flourishing down there. If you are a germaphobe, that probably sounds like a total nightmare. But honestly, it's not that bad. For one, they don't even look gross. These rusticles actually look kind of cool, like ice crystals or tiny diamonds clinging to the wreck. And don't worry, you are not in danger. As long as you keep a safe distance from the wreck, no direct contact, and definitely don't go poking around inside, there really is no risk. Speaking of getting dangerously close, we've got to mention the Titan submersible disaster. You know, the one that catastrophically imploded back in 2023 during a trip to the Titanic wreck. Sadly, all 5 people on board lost their lives. Even though this trip was sold as a tourist adventure, going that deep in the ocean is no joke. It's terrifying, cold, and dark. Sunlight gets absorbed by water and can't reach much farther than about 3,300 feet below the surface. Past that point, the ocean is in total darkness all the time. Titanic lies within a region known as the Midnight Zone for this very reason. The few brave people who have visited the wreck say the descent takes over 2 hours through complete darkness. Then, out of nowhere, the ocean floor just pops into view, lit up by the submersible's lights. The second big challenge is actually finding the wreck. At that depth, navigating is no easy task. When you reach the bottom, you really don't know exactly where you are. You're just kind of fumbling around in the dark, knowing that Titanic is somewhere down there, but you can't see it. However, detailed maps of the Titanic site, made from decades of high-res scans, really do help. As the wreck starts to come into view, they can use those maps to stay on track. Plus, sonar and sensors let the crew notice features and objects even if they're way beyond the sub's tiny light pool. For example, the Titan submersible had a sensor called the Doppler velocity log. This one sent out sound waves to measure how fast the sub is moving and how deep it is, based on its distance from the ocean floor. Still, passengers on previous trips to Titanic in this submersible have said how tough it is to find their way once they reach the ocean floor. And we can't forget about the pressure. The deeper you go in the ocean, the more pressure the water puts on everything. And the pressure is crazy high at the Titanic's wreck site. To put it into perspective, it is about 200 times the pressure inside a car tire. That's why submersibles need super thick walls to handle it. So yeah, the water around Titanic has creepy microbes, pitch-black darkness, and insane pressure. But there is one more thing happening down there, and that's unpredictable currents. You're familiar with them. I mean, when you swim in the sea, you can usually feel the currents pulling you from side to side. But the deep ocean has its own set of underwater currents too. They're not as strong as the ones you feel on the surface, but they can still move massive amounts of water around. These currents can be caused by things like wind, differences in water temperature and salt, and even strange storms down on the ocean floor called benthic storms. They can get intense and stir up the sea bottom. Now, like I mentioned earlier, the Titanic wreck is in two big pieces, the front and the back, and researchers have been checking out the seabed of the surrounding area. One part of the wreck is near this cold underwater current called the Western Boundary Undercurrent. It flows south and moves mud and sand along the ocean floor, creating ripples and patterns that show how strong or weak the current is. Most of the time, the currents there aren't very strong. They even found sand ripples near where all the Titanic debris landed, like furniture, coal, and just random stuff from the ship. And those ripples are showing a current flowing from east to west. But inside the main wreck site, things get a little wilder. The water flows more from northwest to southwest, probably because all the huge chunks of the ship are messing with the flow. Around the south side of Titanic's bow, the currents get unpredictable too. They keep switching directions, from northeast to northwest to even southwest. It's like the ocean's just doing its own thing down there. Experts think that over time, all this shifting water is going to slowly bury Titanic under layers of mud and sand. Little by little, the wreck could just fade away and disappear beneath the ocean floor. Alright, now it's time to get to the obvious issue here: icebergs. Yep, they're still a problem for ships today. In 2023, around 380 icebergs flowed into the busy shipping routes between North America and Europe. That's a problem. You see, the bigger the iceberg, the easier it is to spot and avoid. Smaller ice is a lot harder to detect, though it's no less dangerous. And that's because the most dangerous part is underwater, where no one can see it. Think about the iceberg that sank Titanic. Passengers saw about 100 feet of it above the water, but it's believed that's only 16% of its total size. Experts say the rest, hidden beneath the waves and much larger than what's visible, could stretch down several hundred feet. Now, the good news is that, unlike Titanic's day, we have much more technology now to spot icebergs in time. Modern ships have radar and satellite imagery that can pick up icy threats hiding in the dark. Some vessels even use sonar and thermal imaging to see through fog, helping the crew to spot icebergs above the surface. GPS and AIS pick safer routes, and monitoring centers around the globe send out real-time alerts, like having a personal iceberg spotting assistant. So, yes, it is a massive upgrade from just relying on binoculars. You won't have to worry about icebergs on your next cruise vacation, even if it passes alongside Titanic's route. But just to be extra safe, try not to travel with anyone named Jack or Rose, and never play the violin while on board. Just saying. Guess what? A huge ocean might be hidden deep beneath us, about 250 to 400 miles down, and it's bigger than any ocean on Earth's surface. Scientists were listening to earthquakes deep within our planet and noticed how these shakes slowed down when passing through certain parts of the mantle. This suggested that water was there, Models and experiments led them to uncover the underground ocean. But this ocean isn't like the typical water you imagine. It's a lot crazier. The mantle is a thick layer between the Earth's crust and core. It consists of the upper mantle, the lower mantle, and a mysterious layer between them called the transition zone. In the upper layer, we can often find a fascinating material called olivine, which got its name from a pretty greenish color. Olivine doesn't care about high temperatures and thrives in lava comfortably. It not only thrives, but it even makes up 50% of the entire upper mantle. We can find this stuff on Earth thanks to volcanoes. When volcanoes spew their magma out, all the minerals in it make their way to the surface. As magma cools and solidifies, it forms igneous rocks, and the minerals start to crystallize. Olivine is one of the first minerals to crystallize, and since there's so much of it in magma, it forms lots of crystals. Sometimes they're small, but sometimes they grow large and become very noticeable. We collect these large gemstones and use them to make pretty accessories and for other purposes, such as casting metals. But as we dive deeper within the Earth, about 250 miles down, things get strange for olivine. We enter the mysterious transition zone. The pressures get way higher, and the temperatures rise significantly. Here, olivine transforms into beautiful rock called wadsleyite and ringwoodite. Just like with olivine, we sometimes find them thanks to volcanic activity. Both are blue-green with a beautiful glassy appearance. Unfortunately, they're exceedingly rare and small, so you can't make accessories out of them. They're usually studied in labs. But they can do something that olivine can't. Thanks to their structure, they can act like a sponge, soaking up water. Now, this doesn't mean that they're literally wet. Rather, wadsleyite and ringwoodite can store water components, hydrogen and oxygen, within their structure. Usually, up to about 3% of them are water particles. These two little guys play an immense role in our planet's geology. They influence how the Earth's mantle conducts electricity as well as its viscosity, or how well it flows. This affects mantle convection, plate tectonics, and even volcanic activity. Without these tiny crystals, our planet would be completely different. The world could be mostly underwater, with just a few mountaintops visible. They also help us better understand how water works in general. So, the transition zone is special because it's hydrated. Here we come to the recent discovery, a massive underground water reservoir. Scientists try to understand how water behaves in this deep part of the Earth. They discovered that as water-rich ringwoodite moves even deeper into the Earth to the lower mantle, it can start to melt a bit. This means it can release a bit of water and then trap it somewhere underground instead of letting it move around freely. But this released water wouldn't really be in its liquid, solid, or gas forms. Instead, it would be chemically bound to the underground structures. So, it won't be an ocean in the traditional sense, but there might be a vast amount of water down there. This finding is super important because it changes the way we understand Earth's water cycle and resources. It turns out that water isn't just found on the surface, but also moves through hidden spaces deep inside the planet. Another fascinating thing we discovered about water is that it might exist in a mysterious fourth state of matter. Now, we're used to thinking of water in its three common states: solid, liquid, and gas. But under extreme pressure in tiny spaces, it can enter a mysterious fourth state known as tunneling. We discovered this strange behavior in the mineral called beryl. Within beryl, there are super small six-sided channels, just about 5 atoms across. Turns out these channels act like tiny cages that can trap individual water molecules, like wadsleyite and ringwoodite. In these conditions, the water molecules start showing behaviors that are closer not to classical physics, but to quantum physics. Quantum tunneling allows particles to exist in multiple places at once or pass through barriers they shouldn't be able to. Imagine a ball that somehow ends up on the other side of a hill without climbing over it. It just goes through the hill. Hydrogen atoms in Burl are like tiny balls. Typically, each ball would sit in one specific spot. However, in the experiment, these hydrogen atoms didn't stay still. Instead, they were found simultaneously in multiple spots. Together, they formed a pattern that looked like two wavy rings. It's like water molecules got smeared around in a ring shape. This is a state of water that we've never seen before. It reshapes our understanding of how water behaves under certain conditions, and it has huge implications for biology. All these discoveries have everyone rethinking where Earth's water really comes from. Water is essential for life as we know it. About 71% of Earth is drenched in water, and humans are mostly water too. When we figure out how it appears in space and on planets, it will give us clues about how to better search for extraterrestrial life. One theory says that when Earth was forming, the materials that clumped together to make the planet already included water, or at least the ingredients to make it. Earth formed about 4.5 billion years ago. Our planet slowly emerged thanks to gravity from dust, gas, and rocks that surrounded our newborn sun. This material gradually came together to form the planets of our solar system. However, the young inner solar system was a scorching place, too hot for any liquid water to survive. It would have simply vaporized and escaped into space. But it's possible that water was trapped inside the rocks that initially formed Earth. Some of the Earth's original building block contained much more hydrogen than all our oceans combined. It would also explain how water molecules got so deep underground. Then, volcanic activity could have later released the water stored deep within, sending it into the atmosphere as vapor. This vapor would eventually cool down, condense, and fall as rain, filling the young Earth with lakes and seas. Another idea is that after Earth was formed, water was brought here by wet space visitors like comets and asteroids crashing into the planet. Long ago, the inner solar system was a wild and chaotic place, much like Brightside. When the outer planets rearranged their orbits, this caused a ripple effect, which we now call the Late Heavy Bombardment. It sent a flurry of icy space rocks crashing through the inner solar system, many of which collided with Earth. For a while, scientists thought that this event and comets were a primary source of Earth's water. But then, we learned that comets have a different chemical makeup from the water on Earth. Then we looked at the asteroids. Their water closely resembles the water in Earth's oceans. Some of the samples even contained organic materials. There's also a chance some random planet helped us out. About 4.5 billion years ago, a Mars-sized planet named Theia is thought to have collided with Earth. It was a violent encounter that melted part of Earth's mantle and led to the formation of the Moon. Perhaps Theia also brought some water with it. And finally, Earth could have generated its own water. Chemistry says that hydrogen could react with molten rock in vast magma oceans to produce seas and oceans. It's also possible that all these ideas are true, and Earth's water came from several sources. It complicates our research, but shows how dynamic water can be in space.
Oh wow, there's a hole in the bottom of the ocean. It seems that the ocean has a leak. But it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so. which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960. And it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia. A road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found, hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn.
Deep under the Indian Ocean, there's a giant patch where gravity doesn't work like on the rest of the planet. I mean, the gravitational pull works constantly, but Earth is not a regular sphere. Its surface is not smooth. It's covered with lumps and bumps like a potato, because our planet is not the same everywhere inside. Some parts are denser than others. Let's say you could pour water across Earth's surface. The shape this water would make is called a geoid, and it's like that because of the differences in materials inside the planet. That's why gravity isn't the same everywhere, and down there in the dark depths of the Indian Ocean, it's weaker than usual. That spot is something we consider a giant gravity hole that stretches more than 1 million square miles in size. It's roughly where the ocean floor sinks down in a giant depression. Scientists used ships and satellites to figure out this mystery. They realized the water level near India was lower because of this weak gravity spot. They're still not sure what made gravity become so weak in that area. But 2 Indian researchers realized everyone was trying to understand this considering what that area looked like in the present. So they decided to go to the past. They used computers to make models of a virtual Earth and figured out that the answer could lie over 620 miles under the surface. That's where a part of an old ocean sank 30 million years ago, causing a hot melted rock to move around. And this mixture might have made gravity weak in that area. It's a really interesting idea, but it's still not the final answer. In 2018, a team of scientists from India went to the Indian Ocean with special machines to listen to the ground rumbling, similar to when you hear thunder. They found out there were hot streams of melted rock coming up from deep inside Earth. Could they be part of the reason why the gravity is weak there? We'll need more information to understand the issue better, maybe even go back further into the past. For instance, about 140 million years back, the land was all connected as a big piece called Gondwana. But then, India started moving away from it. While India was moving, an old ocean floor called the Tethys Sea sank into Earth's insides. These two scientists from India kept trying to solve the case, using computers to pretend to be going back in time. They checked how the land moved, as well as the mantle, which is basically a thick layer of hot, solid rock. The duo found out that a long time ago, there were hot, light rocks rising from deep inside Earth. These rocks created a spot where gravity was weak. This spot was like a big dent in the ocean floor. The more these rocks rose, the deeper the dent became. The first of these rising rocks popped out around 20 million years ago to the south of the weird gravity dent. As these rocks moved and went under the land, the dent got bigger and stronger. The two scientists think these rocks were pushed up by the sinking old ocean floor, like bubbles. This process disturbed something called the African blob. You gotta see this. Deep inside our planet, there are two very big blobs, like giant pieces of rock, as large as continents. One is under Africa, and the other is under the Pacific Ocean. These blobs have roots that start almost halfway, 1,800 miles, toward the center of Earth. And they're probably the place where columns of hot rock rise up from way down below. When these hot rock columns reach the surface, big volcanic eruptions happen. And we're talking about some really massive ones that might have even played a role in erasing dinosaurs from the face of the Earth a long time ago. So, we don't want these giant blobs to be disturbed. Anyway, not all scientists agree with the theory about why gravity doesn't do its job in this particular spot in the Indian Ocean, saying they need more proof to be sure about these rising rocks. The real answer might come from listening to Earth's rumbling. Plus, who knows if this gravity hole will stay there forever or move away. It depends on how Earth's mass will shift around. To see some changes might take a very, very long time, maybe even hundreds of millions of years. That's not the only region where gravity works in mysterious ways. Or at least, that's what it feels like when you see certain things around the world. Like, what if you saw rocks that don't sink, but can float on water for a very long time? They can even travel around for thousands of miles until they finally find a spot where they sink. Scientists figured out how this worked by using special X-rays to check the insides of these rocks. And these unusual rocks turned out to be very light and full of tiny holes. Researchers used wax to cover pieces of these rocks and went with a special X-ray method to look inside the rocks to see how much water and gas was there. The reason these rocks can float is because of something called surface tension, which is like a very thin, the size of a human hair, layer of air on the water's surface. This helps some animals, like lizards and insects, to really walk on water. And these floating rocks are not just cool because they travel, but also because they can actually help scientists find underwater volcano eruptions. They can also carry living things across oceans since they tend to collect some plants and other things rich in nutrients. So it's basically like a free cruise, until you sink down at some random spot. No iceberg needed. Here you have floating rocks. And in Death Valley in California, there's a strange phenomenon where big rocks move across a dry lake bed and leave trails behind them. People wondered how this was possible for 60 years until the case was solved. Some thought there must be strong winds moving these rocks, or maybe even ice. But scientists found these winds aren't really strong enough to move such big boulders. They placed cameras on cliffs near the rocks, even though they were hard to reach. They did this for 3 winters in a row to study the temperature, rain, and wind in the area. Their idea was that ice might lift the rocks and let the wind push them. To test this properly, they put a rock in a container with water and sand and froze it. When they later pushed the container, the rock moved like it was on ice. This experiment helped prove their theory. And what's interesting is that the rocky area in Death Valley is similar to one of Saturn's moons, Titan. So these weird things on our planet may help us understand other phenomena, even in space. The Reverse Waterfall in England is an example of a spot with weird gravity too. You can find it not far from Hayfield. It has water that looks more like a fountain than a waterfall, considering it goes up toward the sky. But it turns out gravity doesn't have anything to do here. It's just the wind. It's so strong that when the water falls down, it catches it and pushes it back up. But where does this constantly strong wind come from? You can see a similar thing at Hoover Dam in Nevada, US. Try to climb up the dam, 726.4 feet, and pour some water out of a bottle. Not working? Yep, the water won't flow down as it normally would. It will fly up. You'll have the same result if you throw some light object from the same height. You will get it back. And this happens because of the strong airflow too. So, these things seem like gravity is messing up with us. But there's always a logical answer behind that. Hopefully, we'll get one for the gravity hole in the Indian Ocean too.